What up, class? It's like my millionth time trying to record this video. I miss all of you. Hope you're not bored to death. If you have any ideas on how to keep yourself from bored, I would love to hear them at the end of this video because I am bored. Other than spending all this time doing lessons, none of the things that I like to do besides like reading and watching TV I can do anymore. So please let me know if you're doing any curling with Roombas or making some awesome dominoes, or if you got some puzzles going on, or you got, I don't know, whatever you're doing, please give me some cool ideas to keep myself occupied. Human-sized Jenga. Okay, so let's get to the lesson. We're going to do today's lesson 5.1.1. We're learning about inverse functions. The topics we're going to be covering are the definition of inverse functions, inverse function notation, and how to undo equations. Now, to get us started on the definition of an inverse function, we're going to start with this problem. It's here's a picture of a function machine. So we're gonna talk about Anita's function for a while. Remember, function machines, you got an input that goes in the machine and your outputs come out the machine. And then along with this function machine, we're gonna have a table for Anita's original function. So Anita puts a 3 into the machine, so you can see it's going into the machine here, and it's an input here on the X side of the tables, and then out comes a 7. Then she puts a 4 in the machine, and out comes a 9. And then she puts in a -3 in the machine, and out comes a -5. Okay, so that's what her function machine does. But then Anita's function machine suddenly starts working backwards. It begins pulling outputs back into the machine. So you can see now the arrows have changed. Now it's pulling the outputs back up into the machine, reversing the machine's process and returning the original input. So Anita's backwards function, you have a table for that as well. So it pulls out a 7. Remember, that was one of our original outputs. So it's pulling it up out of the up into the machine, and so since because it's going into the machine here, it's in the X category here for her table. And out comes the 3, which remember that was the input for her original function, so it sucks the output, and then out comes the original input, right? And then it gets the pulls out the 9, and then out comes the 4. Oh. Okay, and then what would you expect if a -3 is sucked up in the machine? What do you think that will come out? That's right, a -5. Okay, so what is the equation of Anita's original function? So here's your table of values. What do you think her equation for original function is? That's right, it's the equation of original function, which we'll call f, is 2x plus 1. And then what about Anita's backwards function? What do you think the equation of Anita's backwards function is? That's right, the equation of our backwards function, which we'll call g, is g of x equals 1/2 x minus 1/2. Okay, so that's the basic idea of an inverse function. So Anita's backwards function is called an inverse function of f of x. So g of x is an inverse function of f of x. That's because what it does to, because it does the opposite. The input, what were the outputs are now the inputs, and what were the inputs are now the outputs. It basically undoes what Anita's original function does. So, okay, let's explore that some more. So, here's a function machine for f of x equals 5x plus 2. So if the crank is turned backwards, what number should be pulled up in the machine to have a 4 come out of the top? So that's the question. What number here needs to be pulled up to have a 4? So basically, let's figure it out. So to have a 4 come up at the top, right, then if it were going the other direction, right, you would have 5 times 4 plus 2, right? 4 gets substituted for the x, which equals 20 plus 2, which equals 22. So 22 must be the thing that gets sucked up and pulls out of 4. All right, so Kiko wants to build a new machine that will undo what f of x does. So what must Kiko's machine do to undo to 17 to undo f of x and return a value of 3? Basically, so here we go. What would basically the operations that need to be done to 17 to undo what this function inside does to come out a 3 at the top? So to undo the adding here by subtracting 2, and then remember x is also, so it's being added to and then multiplied by 5, so now 17 becomes 15, and then you need to undo the times 5 here by dividing by 5, so you get 15 divided by 5, which gives us 3, right? So those are the operations. Instead of adding 2 to undo, you subtract 2, and instead of multiplying by 5, you divide by 5, right? So let's go over that. So the original function operations, right? The original function operations is you're adding 2 here and multiplying by 5 here. So the undo function operations are subtracting 2, as you can see here, and then the dividing by 5 here. Okay, so that's kind of how you, that's the beginning of thinking on how to create an undo function. Figure out what operations are going on in your original function, and so what operations do you need to undo those original functions. So again, let's explore that some more. So let's try to figure out what our undo function is. So our original function, remember, is f of x equals 5x plus 2. Right, when it goes this direction. And you could also say it's y equals 5x plus 2. Now, we know that all the x, from the last example, we know that all the x values of the original function become the y values of the inverse function, and all the y values of the original function become the x values of the undo function. So like the original function, right, we said had the point 317. The undo function must have the point 17.3. So, right, so if it went this direction, it was 317. If it went the other direction, it's 17.3. So let's switch x and y of our original function here. So it becomes x equals 5x, or 5y plus 2, and then we'll solve for y. So to solve for y, right, we need to isolate y here. So it's adding 2, so we first subtract by 2, right? And then we get x minus 2 equals 5y. And then we still need to isolate this, right? So it's multiplying by 5, so you need to divide by 5. And then now y is isolated. You get y equals x over 5 minus 2/5. Or you can rewrite the other one, y equals x over 5 minus 2/5. Okay, and this is our undo function. So this is the undo function of this function. Okay, so this is the second topic, right, that we talked about. So we talked about how we were going to go over the original definition, which we did, and then we were going to talk about the notation. This is the notation. So here we go. Remember an undo function. This undo function, y equals x over 5 minus 2/5, is called an inverse function. And it has this notation, f to the negative 1. Okay, note that the negative 1 is actually not a negative exponent. It is the mathematical symbol that indicates that this is the inverse function of f. Okay, so there we go. We covered the 3 topics. We know the general idea, right? The inputs and the outputs switch for inverse function, and then we learned how to undo the original function to make an inverse function, and this is the notation here. So f here to the negative 1, that's pronounced f inverse equals x over 5 minus 2/5. Okay, and you can always check your answer once you undo your function, right? So we know that the original function has a 0.317, so the undo function has a 0.173. So you can take your inverse function here and you can plug in 17 and you should get 3, right? So plug in 17, you get 17 over 5 minus 2/5, right? And then these have like denominators so that you can combine them to get 17 minus 2 over 5 multiplies to 15 over 5, and 15 divided by 5 is 3. Okay, so summary. So we went over the definition of the inverse function. An inverse function is a function that undoes the operations in the original function. And if the point xy is on the original function, then the point yx is on the inverse function. And then the inputs of the original function are the outputs of the inverse, and vice versa. And then an inverse function notation, right? That's a second topic that I said we'd cover. It says if the function g of x is the inverse function of f of x, then g of x can be written as f inverse of x. So here's again the notation. And then to undo equations, to solve for the inverse function, what you want to do is you want to switch x and y of the original functions, right? Like just we did, and then you solve for y using inverse operations. Alright, so that's the lesson for today. I hope it was useful. I hope you answered all the questions correctly. And again, at the end of this video, please tell me what to do for fun.